Dear students, Assalamu alaikum. Today we are going to discuss a very important chapter in your chemistry, the carbon and its compounds. This chapter, it is chapter number 3 in your chemistry textbook, and it is related to organic chemistry. Carbon and its compounds. In this chapter, we will be discussing what is carbon, where it is present, what are its physical properties, what are the different chemical properties of carbon, what are its uses, and how does it affect our day-to-day life. Also, we will be discussing what are the compounds of carbon, what are the different compounds of carbon, what are their properties, and how we use these different compounds of carbon in our lives, in our day-to-day lives. Carbon, it is an element with symbol C. Carbon is an element, its symbol is C, and its atomic number is 6. Carbon is an element, its symbol is C, and its atomic number is 6. What does this mean? In your previous classes, that is class 9, you studied what is an element. Element is basically the substance which is made up of same type of atoms. The substance which is made up of same type of atoms is called an element. You have discussed this in your previous class. I will not go into the details. And there are different elements, more than 118 elements in nature. These elements, in order to make their study easy, we have assigned certain symbols. The scientists, they have assigned certain symbols to each and every element according to certain rules. This also you will have studied in your previous class, that is class 9. What are the different rules regarding symbolization? I will not discuss here. I am concerned here with atomic number. The atomic number of this carbon, it is 6. What does this mean? What is atomic number? Atomic number, it is basically the number of electrons present in various shells of an atom. The number of electrons present in various shells of an atom, this is atomic number, and it is denoted by Z. The basic definition of atomic number is the number of protons. The number of protons present in the nucleus of an atom. But in a neutral atom, mostly the atoms, they are neutral in nature. In a neutral atom, the number of protons and number of electrons, it is equal. So we can say that it is the number of electrons present in various shells of an atom, and mostly in chemical reactions the electrons take place. So we denote the atomic number as the number of electrons. This atomic number. The atomic number of carbon is 6. What does this mean? As I have written here, number of electrons present in various shells of atom. That means the carbon, it has 6 electrons. Carbon has 6 electrons present in its various shells. And how these are arranged, how these 6 electrons are arranged in various shells, we will discuss further. Before that, we will discuss where the carbon is present in nature and in what form. Carbon, it is present in nature, it is present in Earth's crust. Carbon is present in Earth's crust in the form of carbonates and in the form of fossil fuels. Fossil fuels, that is coal, petroleum and natural gas. This present in Earth's crust in the form of carbonates, in the form of fossil fuels, that is coal, petroleum and natural gas. And also it is present in atmosphere. In the form of carbon dioxide. Carbon is present in atmosphere in the form of carbon dioxide. But its percentage, the percentage of this carbon present both in Earth's crust as well as atmosphere, it is very low. In Earth's crust, the percentage of carbon, it is almost 0.03%. Only 0.03% of carbon is present in Earth's crust, and percentage of carbon dioxide in atmosphere, it is almost 0.02%. But when we look around in our surroundings, we see that the carbon, it exists everywhere. For example, if you look at the bodies of plants and animals, the plant bodies, almost all parts of the plant and animal, they are made up of carbon compounds. When we look at our clothes, these are made up of cotton or some synthetic fibers, but mostly they are made up of carbon. When we look at our food, it is made up of carbohydrates, the proteins, the vitamins, the minerals, fats, lipids. These fats, lipids, carbohydrates, their major constituent is the carbon. Looking at Earth's crust and atmosphere, the percentage of carbon is very low. But when we look in our surroundings, we see that the carbon, it exists everywhere. What is the reason for this? The reason for this we will be discussing. Why is carbon present everywhere despite the fact that its percentage is very low in Earth's crust and in atmosphere? There are certain reasons for the versatile nature of this carbon. This versatile nature, it makes the carbon make different types of compounds, which is the reason that we see this carbon in our day-to-day lives in each and every part and sphere of our life. First reason is the tetravalency of the carbon. Tetravalency of the carbon. What does this tetravalency mean? Carbon, as you know, its atomic number is 6. Here, I will draw the structure of a particular carbon atom. This is the nucleus, and these are the shells. Carbon has 6 electrons, and these 6 electrons, they are arranged in 2 different shells. This is A shell and this is L shell. There are 2 electrons in the K shell and 4 electrons in the L shell. Valency is the number of electrons which are gained, which are lost, or which are shared by an atom. This carbon, it has 4 electrons in its valence shell. So these 4 electrons, it shares these 4 electrons, so its valency is 4. That is tetra. Tetra means 4. Valency is the number of electrons which are gained, which are shared, or which are lost during a chemical reaction. So it is tetravalent in nature. This arrangement of the electrons in various shells of an atom, this is called as electronic configuration. Electronic configuration. So, electronic configuration, it is the number of electrons present in various shells of an atom. Now, what are the rules? How this electronic configuration is done, and what are the different rules to fill the electrons in various shells? We will discuss first so that we understand how these 6 electrons are distributed in the various shells, in different shells of this carbon atom. Electronic configuration. Electronic configuration, it is the number of electrons, or we can say it is the arrangement of electrons. It is the arrangement of electrons in various shells. In various shells of an atom. In your previous class, you have discussed the structure of an atom. The atom, basically, it is made up of 3 types of particles. One is the electron, second is the proton, and third one is the neutron. The protons and neutrons, they are present in the nucleus, while the electrons, they revolve around the nucleus in the elliptical parts, which we refer as shells. Now, electronic configuration, what is the number of electron a particular shell can accommodate? This is governed by Bohr-Berry rule or Bohr-Berry scheme. The Bohr-Berry rule, that is 2n square. Niels Bohr, he devised a rule which is called as Bohr-Berry rule or 2n square rule. And according to this rule, the maximum number of electrons which an element or which a shell can accommodate, it is equal to 2n square. What does this 2n square mean? Before discussing this, I will draw here the structure of an atom. To simplify this 2n square, this is the nucleus of an atom. This is first shell or path around this nucleus. This is second shell. This is third shell. This is fourth shell. So this is the nucleus of an atom. And these circular or elliptical paths, these are called as the shells. The first shell, which is closer to the nucleus, this is referred to as K shell. K shell. After that, the second shell, which is after this K shell, it is L shell. This is referred to as M shell, and this is referred to as N shell, so on. These are the different names of different shells. This is nucleus, and around the nucleus there are various paths. And inside these paths the electrons revolve. The nucleus, it is made up of the protons and neutrons. Nucleus is made up of protons and neutrons. Protons are positively charged and neutrons, they are neutral in nature. They have no charge. And the electrons, which have negative charge, they revolve around this nucleus. The electrons, which are negatively charged particles, they revolve around this nucleus. Now, what is the number of these electrons which revolve around this nucleus in these elliptical paths or circular paths? What is the maximum number of electrons this shell can accommodate? It is governed by 2n square rule. We will simplify this 2n square rule for each and every shell, that is K, L, M and N. Here, this is K shell, L shell, M shell and N shell. Applying 2n square, n is the number of shell. 2 is a number, and why this n, it denotes the number of shell. What is the number of this shell? Here K, it is number first, L is number second, M is number third and N is number fourth. These are the numbers assigned based upon their proximity to the nucleus. So K, it's here, the N for K it is 1, N for this L it is 2, this N for M it is 3, N for N it is 4. This N, the number, this N, it refers to the number, where K, its number is 1, L, its number is 2, M, its number is 3 and N, its number is 4. Now, we will apply 2n square rule to this K shell. Here, 2n. In the place of this n, we will put its value. Here, n is equal to 1. For K, n is equal to 1. 2 into 1. And this square, after simplifying, we see that is 1 raised power 2, that is 1 into 1, that is 1. 2 into 1 is equal to 2. So this is the maximum number of electrons K shell can accommodate. That means K shell can accommodate maximum number of 2 electrons based upon or according to 2n square rule. Now simplifying 2n square for L, 2 into n here, n is equal to 2. 2 into 2 raised power 2. So 2 into 2, 4. 4 into 2, 8. That is 8. That means L shell, it can accommodate the maximum number of 8 electrons. M. For M, we will devise the 2n square rule. Here n is equal to 3. 2 into 3 raised power 2. This is 3 raised power 2. That is 3 into 3. 3 3s are 9. 9 into 2. That is 18. So the M, it can accommodate maximum of 18 electrons. And N, here N is equal to 4. 2 into 4 raised power 2. That is 4 into 4. 4 4s are 16 into 2, that is 32. So K shell can accommodate maximum of 2 electrons. L shell can accommodate maximum of 8 electrons. M shell can accommodate maximum of 18 electrons, and N shell can accommodate maximum of 32 electrons. Now we will apply this 2n square rule to carbon. Here the atomic number of carbon is 6. That means carbon has 6 electrons. Now applying 2n square rule, that is L can accommodate, K can accommodate 2 electrons, L can accommodate maximum of 8 electrons. But when we subtract 2 electrons from 6, the 4 remain. So these 4 electrons, they are present in the next shell, that is L shell. So L shell, it has maximum of 4 electrons in carbon. So we say that the electronic configuration of carbon is K2. That means K, it has 2 electrons and L has 4 electrons. And its valency, or the number of valence electrons, the number of electrons present in the outermost shell, that is, it has 4 electrons, and these electrons, carbon uses these 4 electrons. It shares these 4 electrons with 4 different elements. So its valency is 4. That means carbon, it is tetravalent in nature. Tetravalent in nature. So this property, it makes the carbon special. It can form a large number of compounds with different types of elements. So this is one of the reasons that we see that the carbon, it is present in large numbers in almost all the compounds which we see around us. So I think this is enough for today. We will discuss other properties of this carbon which makes it unique in our next chapter. Till then, Khuda Hafiz.